Good night and welcome back to Fundamentals of Engineering with Mechanics of Materials. Maximum stress in flat bar with fillet. Sigma maximum calculation. So in this example, we want to know if we have like a flat bar with fillet with a radius of once 12 millimeters and then in part B 18 millimeters with the allowable stress of 125. We want to know what would be the maximum value of P which we can apply to this structure. The dimensions like the depths in the thicker in the wider part is 120 millimeters. The width in a narrower part 60 millimeters, radius is 12 and 18, and the thickness of the plate is 50 millimeters. We are looking for the maximum P which we can apply to such a structure. Stress concentration in fillet bar are distributed like what we can see below here. So if we had like a flat bar with fillet and apply a tensile force, you can easily see this is the stress distribution near fillet. So near the fillet, sigma is maximum, and as it moves to the center, it just decreases, but we use the sigma average for the entire system. In such a structure, we need to jump to this table based off the radius of fillet to the width of a smaller section, narrower section, and also d capital to d lowercase ratio. We'll read the chart for the value of k. So our dimensions are provided. Area is the narrower part times the thickness of the plate, which is 60 times the thickness, which is 15 millimeters, and that make it like 900 millimeters square. 900 times 10 to negative 6 meters squared, and capital D over lowercase d is 120, as you can see here, to 60, and that's equal to 2. So definitely our chart is this one. D over D is equal to 2. So it is our uh, curve is the very first curve from this chart. And then we need in part A, we have radius of 12 millimeters. R is equal to 12 millimeters radius to depth of narrower part is width of narrower part is 12 to 16, 12 to 60 millimeters, and that's equal to 0.2. And if you read lowercase r over d, that's 20 or 0.20. And if you just read that up to the uh, desired curve and read it from the vertical part, it just shows like something between 1.8 and 2, and that's equal to 1.92, for example. Then sigma maximum is equal to this factor times a force over the area. If we look for the maximum force applied to the force, that's area times sigma maximum divided by k. And if put the numeric value, replace numeric value in the equation of P, it just gives you A, which is just come from here. And then 900 millimeters square. It should be, my bad, it's 900 times 10 to negative 6, because 900 millimeters square, each millimeters, that's the correct answer. Yes. Then times 125, which is megapascal, which is the allowable stress, sits for sigma max, and K, which we read it from the chart, sits here, and our P will be equal to 58.6 kilonewtons for part A. Do the same for part B, but this time with different radius, like 80 millimeters. If you increase the radius from radius of fillet from 12 to 18, this time D over D remains the same, R over D, 18 over 60, it's 0.30. So 0.30 is the this number here, come up and read the curve, and that's like k is equal 1.75. Do the same math this time for p, and it just gives us a p is equal to 64.3 kilonewtons. If we want to make a comparison between the same structure with the radius increase from 12 radius of fillet to R is equal to 18 millimeters, then sigma maximum for A is equal to 58.6 kilonewtons, and as the radius of fillet is increasing, sigma maximum also increases to 64.3 kilonewtons. Definitely that's higher than A. Thank you. We'll solve more problems related to stress concentration.